welcome to Number Crunch. Today we shall be tackling KCSE 2018 Paper 2 Section 1 starting from question 1. It states, given that 2 log x squared plus log square root of x is equals to k log x, find the value of k. So the expression we have been given is 2 log x squared plus log x, the square root of x is equals to k log x. The first step, we can rewrite the expression to be log x squared raised to power 2, whereby we bring the coefficient of the log to become its power, plus log x, we have the square root of x, and the square root can be written as power a half, is equals to log x raised to power k. Then we open the brackets, we have log x raised to power 4 plus log x raised to power half is equals to log x raised to power k. Then using the rules of logarithms, when we have log a plus log b, we can write it as log a times b, and therefore this can be written as log x raised to power 4 times x raised to power half is equals to log x raised to power k. We open the bracket, since the bases are the same, so we add up the powers. We have log x raised to power 4 plus a half is equals to log x raised to power k. So we have log x raised to power 4 and a half is equals to log x raised to power k. Then notice that in both sides we are looking for the log of x, and that means that since both are the log of x is equals to the log of x, it means that the powers of those terms are equal. Therefore, our k is equals to 4 and a half. Question 2. A variable p varies directly as t cubed and inversely as the square root of s. When t is equals to 2 and s is equals to 9, p is equals to 16. Determine the equation connecting p, t, and s. Hence, find p when s is equals to 36 and t is equals to 3. We've been told that p varies directly as t cubed and inversely as the square root of s. So this can be expressed as p varies directly as t cubed over the root of s, or p varies inversely as the square root of s. Then we've been told when t is equals to 2, s is equals to 9, and p is equals to 16. So the first step is to write the expression as an equation, and to do that we introduce a constant k, which makes our equation p is equals to k t cubed over the root of s. Then we substitute the figures that we have been given, t as 2, s as 9, and p as 16. So we have 16 is equals to k times 2 cubed over the root of 9. This can be simplified as 16 is equals to 8k over 3. Then we multiply both sides by 3 to remain with 8k on one side. So we have 16 times 3 is equals to 8k. 48 is equals to 8k, which can be written as 8k is equals to 48. We divide both sides by 8, and therefore our k is equals to 6. So the equation that connects p, t, and s is p is equals to 6t cubed over the root of s. Then we've been told that when t is equals to 3 and s is equals to 36, we are supposed to find the value of p. So we substitute the figures that we've been given. P is equals to 6t cubed over the root of s, and we've been told that t is 3 and s is 36. So we have 6 times 3 cubed over the root of 36, and this you evaluate this using your calculator, you find that the value of p is equals to 9. Question 3. Asia invested some money in a financial institution. The financial institution offered 6% per annum compound interest in the first year and 7% per annum in the second year. At the end of the second year, Asia had 170,130 Kenya shillings in the financial institution. Determine the amount of money Asia invested. So we need to obtain the principal that was invested at the beginning of the first year, and we've been given the amount at the end of the second year was 170,130. So the first thing is to remind ourselves the formula of compound interest, and it is usually amount is equals to principal into 1 plus the rate times the time. But in our case, we have different rates for year 1 and year 2. So we are going to compute backwards. We first find the amount that was obtained at the end of year 1, which was now the principal of year 2. So we have the amount in year 2 will be the principal invested in year 2 into 1 plus the rate of year 2 times the time, the period of compounding. So we substitute, we have been given 170,130 is equals to the principal of year 2 into 1 plus 7 over 100, which is 7% per annum, and therefore our T will be 1. We simplify this, we have 170,130 is equals to 1.07 principal of year 2. We can rewrite it, then we divide both sides by 1.07, and we obtain that the principal in year 2 was 159,000. Then remember, in compound interest, the principal plus the interest is used as the principal in the next year, and therefore that means our principal of year 2 was the amount of year 1, and so the amount of year 1 was also 159,000. Then we now compute to find the principal of year 1 as we have done for the principal of year 2. We have amount in year 1 is equals to the principal of year 1 into 1 plus the rate of year 1 times the time. The amount we have obtained as 159,000 is equals to the principal of year 1 into 1 plus 6 over 100, which is 6%. And since the compounding is per annum, our T is 1. Then we simplify, it becomes 159,000 is equals to 1.06, the principal of year 1. Rewrite it is 1.06 principal of year 1 is equals to 159,000. Divide both sides by 1.06, and therefore the principal of year 1 was 150,000. And this means the amount that she invested at the beginning of year 1 was 150,000. Question 4. The figure below represents a wedge ABCDEF. EF is equals to 10 centimeters. Angle FBE is equals to 45 degrees. And the angle between the planes ABFE and ABCD is equals to 20 degrees. Calculate length BC correct to 1 decimal place. So we've been given the wedge. And the first thing to note is that in solid geometry, a wedge is a right triangular prism. Therefore, angle BCF is a right angle. Then, since BE bisects angle ABF, it implies that angle ABF is a right angle, and therefore ABFE is a rectangle, meaning that all angles are 90 degrees. And so we can use the basic trigonometric functions to solve the question is being asked to solve, that is to find the length of BC. And the function can be abbreviated as SOHCAHTOA, that is in reference to the sine, which is opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, which is opposite over adjacent. In our case, we've been given angle FBE and length EF. So the first step is to find the length BF, and in relation to angle FBE, our BF will be the adjacent and our EF is the opposite. So we are going to use the tangent function. So tan FBE is equals to EF over FB, which is the opposite of adjacent. we substitute, we have tan 45 degrees is equals to 10 over FB. We cross multiply, we have FB tan 45 degrees is equals to 10. We divide both sides by tan 45 degrees. FB is equals to 10 over tan 45 degrees. You can compute this with your calculator and you obtain that FB is equals to 6.2 centimeters, correct to 1 decimal place. Then the next step is to find length BC. We have been given the angle between planes ABFE and ABCD as 20 degrees, and we have established that angle BCF is a right angle, and so in relation to BC we have length BF, we are looking for BC, and we have angle FBC which is 20 degrees. So using the trigonometric functions, we can use the cosine since we have the adjacent and we have the hypotenuse. And so cos FBC is equals to BC over FB, which is the adjacent, the BC is the adjacent, and FB is the hypotenuse. We substitute, we have cos 20 degrees is equals to 6.2, is equals to BC over 6.2. We cross multiply, we find 6.2 cos 20 degrees is equals to BC, or BC is equals to 6.2 cos 20 degrees. Substitute this with your calculator, you obtain BC is equals to 2.5 centimeters, correct 1 decimal place. Question 5. Simplify root 54 plus 3 root 3 divided by 3. The expression is root 54 plus 3 divided by plus 3 root 3 divided by root 3. So to simplify, the first step is to eliminate the square root in the denominator, and to do that we are going to multiply by a similar factor which is root 3, but in order not to change the expression, so we have to multiply by root 3 over root 3, which is the same as multiplying times 1. Then we multiply the root 3 with the numerator. We shall have root 54 root 3 plus 3 root 3 root 3 divided by root 3 root 3. This can be rewritten as root 54 times 3 plus 3 root 3 times 3 divided by root 3 times 3. Then 54 can be factorized, and therefore we have root 2 times 3 times 3 times 3 times 3 plus 3 root 3 times 3 divided by root 3 times 3. So in the first expression, that will give us 9 root 2 plus 9 divided by 3. Then 9 is common in both factors in the numerator, so we can factor it out as well. We shall have 9 into root 2 plus 1 over 3, and 3 can go to 9 3 times, so we shall have 3 into root 2 plus 1. So the simplification of root 54 plus 3 root 3 divided by 3 is 3 into root 2 plus 1. Question 6. In the figure below, AB is a tangent to the circle center O and radius 6 centimeters. The arc AC subtends an angle of 60 degrees at the center of the circle. Calculate the area of the shaded region, correct 1 decimal place. So we need to find the area of region ACB. And remember, we've been told that line AB is a tangent to the circle, and in the properties of tangents, a line tangent to a circle is always perpendicular to the radius corresponding to the point of tangency. So what that means, our angle OAB is a right angle. Then to find the area of ACB, we need to find the area of triangle OAB minus the area of the subtended sector OAC. And therefore the area of the shaded region will be the area of triangle AOB minus the area of sector AOC. So we will start by computing the area of triangle AOB. And to do that, we know that for a right angle, the area is a half times base times height. We have the height, but we do not have the base. So we need to find the base first. And since it's a right angle, we can use the trigonometric functions to find the length of AB. So we have SOHCAHTOA. In relation to the line OA and AB, we shall use tan, since OA is the adjacent angle to the angle we have been given, and AB is the opposite angle. Therefore, tan AOC is equals to AB, which is the opposite, over OA, which is the adjacent. We substitute, we have tan 60 degrees is equals to AB over 6. We cross multiply. We have 6 tan 60 degrees is equals to AB, or rather AB is equals to 6 tan 60 degrees. You can use your calculator to compute that. You obtain that AB is 10.4 centimeters. So since we have AB, which is our base, we can be able to calculate the area of triangle AOB, which is a half times base times height. A half times 6 times 10.4, which is equals to 31.2 squared centimeters. Then we go back to calculating the area of sector AOC, and it will be the ratio of the subtended angle by r squared, and the subtended angle is 60 degrees. So it's 60 degrees over 360, which is the total pi r squared. So we have 60 degrees over 360 degrees times pi, which I've used as 3.142 times 6 squared. Compute this with your calculator, you find 18.852 squared centimeters. So we have the area of triangle AOB and the area of sector AOC. So the area of the shaded will be the subtraction of the two, and it is 31.2 minus 18.852, which is equals to 12.348. But since we have been asked to give our answer to one decimal place, so the area is approximately 12.3 squared centimeters, correct to one decimal place. Question 7. Use completing the square method to solve 3x squared plus 8x minus 6 is equals to 0, correct to three significant figures. So we are supposed to solve the quadratic equation using the completing the square method. And the expression is 3x squared plus 8x minus 6 is equals to 0. The first step is to make the coefficient of x squared equals to 1. So we are going to divide both sides of the equation by 3, leaving us with x squared plus 8 minus 3x minus 2 is equals to 0. Then the next step, we need to remain with only the terms with x's on the left hand side. So we are going to add 2 to both sides to eliminate it on the left hand side of the equation. Hence we have x squared plus 8 over 3x is equals to 2. Then in completing the square method, we are supposed to add b over 2a squared as the third term, and to do so also on the right hand side. So we shall have x squared plus 8 over 3x plus 8 over 3 divided by 2, which is the same as our b is 8 over 3 and a is 1. That is the coefficient of x squared. So it becomes 8 over 3 divided by 2. Then you square it. And also you should add the same term on the right hand side to balance the equation. So we have x squared plus 8 over 3x plus 4 over 3 squared is equals to 2 plus 4 over 3 squared. Then in algebraic formulas, we know that a plus b squared is equals to a squared plus 2ab plus b squared. And looking at this, the right hand side of the formula, it looks similar to the left hand side of the equation we currently have. And so we can deduce that our a is x and our b is 4 over 3. So we can rewrite that expression as x plus 4 over 3 squared is equals to, we simplify the right hand side, which is 37 over 9. Then we square root both sides in order to remain with x plus 4 over 3, and therefore x plus 4 over 3 is equals to 1.9437, or x plus 4 over 3 is equals to negative 1.9437. Then we are going to subtract 4 over 3 from both equations in order to remain with, to get the value of x. So x plus 4 over 3 minus 4 over 3 is equals to 1.9437 minus 4 over 3, and x plus 4 over 3 minus 4 over 3 is equals to negative 1.9437 minus 4 over 3. So x is equals to 0.6103, or x is equals to negative 3.2770. Remember, we've been asked to give our answer to three significant figures. So in the first case, x will be 0.610. That is to three significant figures. And in the second instance, our x is negative 3.28 to three significant figures. And to delve deeper into the significant figures, I found it wise to share some rules of identifying whether a number is significant or not, especially the zeros. So, the first rule is all non-zero digits are significant. So any number that is not a zero is significant. For example, 67 is a number to two significant figures, and for 75.92 is a number written in five significant figures. Then rule 2, trapped zeros, that is zeros that appear between two non-zero digits, are significant. For example, 4.05.01 is a number to five significant figures. So it means the zeros, the trapped zero between 4 and 5 and the trapped zero between the decimal point and 1 are significant. Then 50,021 is a number written to five significant figures. Leading zeros, that is zeros before non-zero numbers, are not significant. The zeros before a non-zero number are not significant. For example, 0.00532 is a number to three significant figures. Just like we had in our instance where we had our x was 0.6103, the zero before the decimal is not significant, so it will not be counted as a significant figure. Then we have 0.234 is a number to three significant figures, so the zero before 2 is not significant. We have trailing zeros, that is zeros after a number in a number without a decimal place, are not significant. So for example, 100 is a number to one significant figure. The zeros after the 1 are not significant. We have 10,320,000 is a number to four significant figures. Since the zero between 1 and 3 is significant as identified in rule 2, but the zeros after 2 are not significant, therefore the number is to four significant figures. We have trailing zeros in a number containing a decimal point are significant. The zeros contained in a number with a decimal point are significant. For example, 23.00 is a number to four significant figures. Sorry, I've written that one wrongly. It should be four significant figures. Then we have 350,000.00 is a number to eight significant figures. Like in our example, we had 0.610. The zero after the decimal place, the zero which was the trailing 0 after the decimal place, was significant, but the 0 before the number 6 is not significant. We have a lone 0, that is either a 0 by itself is significant, or maybe 0.00 is significant as well. But if there was another number with the 0, then the 0 will not be significant. And lastly, any numbers in standard form are significant, regardless of whether they are zeros or non-zeros. All of them are significant. For example, 3.21 times 10 raised to power 2, that is a number to three significant figures, and 3.6500 is a number to 5 significant figures, meaning the zeros in the number are considered significant regardless. Question 8. 3 workers working 8 hours per day can complete a task in 5 days. Each worker is paid 40 Kenyan shillings per hour. Calculate the cost of hiring 5 workers if they work 6 hours per day to complete the same task. So it means the output of the first set of workers is equal to the output of the second set of workers. And so we can say that the workers times the number of hours they work per day times the number of days is equal to the second set of workers times the hours they work per day times the number of days they will take, since they are to complete the same task. So we substitute with the figures. The first set was 3 workers working 8 hours per day for 5 days. Then the second set is 5 workers working 6 hours per day. We need to find the number of days they take to complete the task. And so 120 is equal to 30 days, which is the same as 30 days is equal to 120. So we divide both sides by 30. We have the days taken were 4 days. Then we find the total hours worked, which is the number of workers times the hours per day times the days. So we have 5 times 6 times 4, which is equals to 120 hours. So the total time taken by the second set of workers was 120 hours. And the rate was 40 shillings per hour. So we need to find the total cost the total cost for hiring the 5 workers. So it is equals to 120 times 40, which is equals to 4,800 Kenya shillings. So it would cost 4,800 Kenya shillings to hire 5 workers working 6 hours a day to complete the same task. Question 9. The table below represents a relationship between two variables, x and y. We have the values of x and y. Part A, on the grid provided, draw the line of best fit. We have the values of x and y, and we need to draw the line of best fit. So that is our y-axis. And the x-axis. This is 0. This is 1, 2, 3, 4, 5, and 6. In the y-axis, the biggest figure is 13. So we can have a scale of 2, 4, 8, of 4, 8, 12, and 16. When x is 1, y is 3.5. So this is 2, 3, 3.5, will be there. While x is 2, y is 4.5. 5, so 4.5. 3, 8.0. 4, 8.5. 5, 11. And 6, 13. Then you are required to draw the line of best fit. For the line of best fit, it should be a straight line and it should touch as much points as possible. Or if it doesn't touch, at least you should try and balance out the points that have been left out on both sides of the line. So we can use these 3 points. If we use the 3 points, points 1, 5 and 6, we shall at least have balanced on both sides and touched as many points. So there we have it. That is our line of best fit, and it cuts the y-axis at, this is 1 and 2, so between 1 and 2, which is 1.5. So this point is 1.5. Y is equals to 1.5. Part B, use the graph to find the value of y when x is equals to 0. So this is the graph that we have drawn in part A, and we can read off the value of y when x is equals to 0. Y is 1.5. Question 10. State the amplitude and the phase angle of the curve y is equals to 2 sine 3 over 2x minus 30 degrees. So the curve that we've been given is y is equals to 2 sine 3 over 2x minus 30 degrees. So when identifying the characteristics of a sine curve, the general form of the curve is y is equals to a sine bx plus c, where a is the amplitude, 2 pi over b is the period, and c is the phase angle. So in our case, we've been asked to identify the amplitude and the phase angle. So relating it to the general form, it means that the amplitude is equals to 2 and the phase angle is negative 30 degrees. However, I've linked some resources on the description to help you further understand and also see some illustrations of the amplitude, phase angle, and the period. Question 11. The mass in kilograms of 9 sheep in a pen were 13, 8, 16, 17, 19, 20, 15, 14, and 11. Determine the quartile deviation of the data. So we need to find the quartile deviation, and to do that, we need to find the quartiles, that is the first quartile and the third quartile. Then we subtract the 2 and divide by 2. That is how you obtain the quartile deviation. So the first step is to arrange the masses in ascending order, and we have them as 8, 11, 13, 14, 15, 16, 17, 19, and 20. Then the general formula of obtaining the quartile number is I into n plus 1 over 4th number, where I is the number of the quartile number, and n is the number of the total number of items under observation, which in our case is the masses of the sheep. So then the number of our interest in quartile 1 is 1 into 9 plus 1 over 4, which is equals to the 2.5 mass. But since we do not have 2.5, so we are going to take the mass number 2 and mass number 3, then divide by 2 or find the average. And we obtain 12 kgs. Then we do the same for quartile 3, which will be 3 into 9 plus 1 over 4th mass, which is the 7.5 mass. We don't have the 7.5 mass, so we take the 7 and the 8th mass, then divide by 2. So it's 17 plus 19 divided by 2, which is equals to 18 kilograms. Then now to find the quartile deviation, we subtract the quartile 3 minus quartile 1 divided by 2. Substitute, we have 18 minus 12 divided by 2, which is equals to 3 kgs. So the quartile deviation of the masses of the ships is 3 kilograms. Question 12. The position of 2 points C and D on the Earth's surface are 0 degrees north, 10 degrees east, and 0 degrees north, 30 degrees east, respectively. The distance between the 2 points is 600 nautical miles. Determine the latitude on which C and D lies. So the first thing to note is that latitude measures how far north or south of the equator a place is located, whereas longitude measures how far a location is east or west of the prime meridian. So in our case, we've been asked to find the latitude, and it's either expressed as north or south of the equator. So in our case, the latitude of point C and D is the same, which is 0 degrees north. But had we been asked to determine the longitude, it would be 10 degrees east and 30 degrees east for point C and D respectively. So the right answer is both point C and D lie on latitude 0 degrees north. Question 13. In the figure below, OP is equals to P, OR is equals to R, PQ to QR is equals to 1 to 2, and PS is equals to 3PR. Express QS in terms of P and R. So that is our figure. The first step, we are going to find PR since we have OP and OR, and PR will be PO plus OR, which can be expressed as negative OP plus OR. So our PR, as you said, will be negative OP plus OR, which is equals to negative P plus R. Then we've been told that PQ to QR is equals to 1 to 2. Therefore, PQ can be expressed as a third PR, which is 1 over the total ratio of PQ to QR. Therefore, our PQ will be a third into negative P plus R, which is equals to negative a third P plus a third R. Then, PS is equals to 3PR, which is equals to 3 into negative P plus R, which is equals to negative 3P plus 3R. With the values of PQ and PS, we can obtain QS in terms of P and R, since QS will be PS minus PQ, which is equals to negative 3P plus 3R minus into negative a third P plus a third R. You evaluate this, you obtain QS is equals to negative 2 over 3P plus 2 over 3R. Question 14. In a certain firm, there are 6 men and 6 women employees. 2 employees are chosen at random to attend a seminar. Determine the probability that a man and a woman are chosen. Note, we've been asked to determine the probability that a man and a woman are chosen, not a man or a woman is chosen. The first step is to determine the total number of employees, which is 6 plus 4, which is equal to 10 employees. Then we determine the probability that a man is chosen, which is 6, since there are 6 men over 10. which can be simplified to be 3 over 5. Then the probability that a woman is chosen is 4 over 10, which is equals to 2 over 5. So the probability that a man and a woman are chosen is equal to the probability of the man being chosen times the probability of a woman being chosen, which is equals to 3 over 5 times 2 over 5, and this equals to 6 over 25. Question 15. Under transformation T is equals to 4 to negative 3, 3, triangle OAB is mapped onto triangle OA prime B prime with vertices O 0, 0, A prime 18, 0, and B prime 18, 6. Find the area of triangle OAB. So we need to find the area of triangle OAB, and we've been told that it was transformed under a transformation T, which is equals to 4 to negative 3, 3, to form a triangle OA prime B prime. So it means that the transformation matrix T times OAB is equals to OA prime B prime. So if we multiply T by its inverse, we shall be able to obtain OAB. Therefore, T times its inverse will form an identity matrix, and so we will remain with OAB is equals to the inverse of T times OA prime B prime. Therefore, OAB is equals to the inverse of T times the coordinates of O, A prime, and B prime. Then the transformation matrix T is equals to 4 to negative 3, 3. So we need to obtain its inverse, and to do that we first need to obtain the determinant, which is 4 times 3 minus 2 times negative 3, which is equals to 18. Therefore, the inverse of T will be 1 over 18 times, we interchange A and D, and then we negative B and C. So we have 1 over 18 into 3 negative 2, 3, 4, which is equals to 1 over 6, negative 1 over 9, and 1 over 6, negative 2 over 9. So that is the inverse of matrix T. Then we were given the coordinates of O, A prime, and B prime as 0, 0, 18, 0, and 18, 6. So we can obtain OAB, the coordinates of OAB, by multiplying the inverse of T by the coordinates of OA prime, B prime. And that gives us 0, 0, 3, negative 2, and 4, negative 2 over 3. So the coordinates of O are 0, 0, of A 3, negative 2, and B 4, negative 3. 4, negative 2 over 3. Then, using the coordinates, we can find the area of the triangle, whereby the area of a triangle given its coordinates is the absolute value of a half into the x value of O times the y value of A minus the y value of B, plus the x value of A times the y value of B minus the y value of O, plus the x value of B into the y value of O minus the y value of A. We substitute, we have the absolute value of a half into 0 into 2 minus negative 2 over 3, plus 3 into negative 2 over 3 minus 0, plus 4 into 0 minus 2. This simplified is a half into 0 plus negative 2 plus negative 8, which is equals to a half times negative 10, and the value is negative 5. Then we find the absolute value of negative 5 is 5. And therefore, the area of triangle OAB is equals to 5 squared units. Question 16. Find the value of k if the integration between 2 and 0 of k x cubed minus 3x squared dx is equal to 16. This question has already been tackled in the integration and differentiation video. So if you want to look at the solution, go to the link. Do you still have an unanswered question? Leave a comment or write an email to guruinmaths@gmail.com and we shall respond within 24 hours. Otherwise, subscribe to receive timely KCSE mathematics revision resources.